Hello friends, today we are starting the basic electronics module with the introduction of digital multimeter. So here in this session we are going to learn what is digital multimeter, its different parts and how we can use it to measure resistance, voltage, current and other parameters. So the table of content, or you can say we have divided this lecture into four parts. In the first part, you will see the introduction, so the basic information about digital multimeter and its parts. Then in the second part, you will see the different applications of digital multimeter, means where this kind of multimeters are used. In third part, we will see how to use digital multimeter to measure different things. And in the fourth and last part, we will discuss how to measure voltage, cable continuity, resistance and current using this digital multimeter. So let's first start with the introduction. So what is this digital multimeter and its different parts? So as we have discussed in earlier lectures that digital multimeters are using widely nowadays. So as its name suggests, it is a meter or it is a device which is giving output in digital range, so you can get outputs in digital form, and using this tool you can measure more than one quantity. So you can whether measure voltage or current of something, or find the resistance of unknown resistors, or check your cable continuity, or check your LEDs whether they are damaged or in good condition. So DMM stands for digital multimeter. A multimeter is a measuring instrument that can measure multiple electrical properties. A typical multimeter can measure voltage, resistance, and current. These are the basic measurement criteria through which you can measure voltage, resistance, and current. So digital multimeters long ago replaced needle-based analog meters due to their ability to measure with great accuracy, reliability, and increased impedance. So digital multimeters are very accurate and we can rely on them because they are very accurate and they have increased impedance. So they have replaced analog meters due to these advantages. So, talking about the advantages, they are more efficient, faster, and work with a large accuracy as compared to an analog multimeter. Now, these are the details. What details we can discuss about digital multimeter is that these test equipments offers several electronic measurement tasks in one tool. So, using this single tool, you can measure variety of electrical properties. It is also known as voltmeter or ohm meter or volt ohm meter. The standard and basic measurement performed by multimeter are the measurements of amperes, volts and ohms. So amperes are the unit for current, volts are the unit for voltage and ohm is a unit for resistor. Apart from that, this digital multimeters perform many additional measurements by using digital and logic technology. So they are improved version of analog meters. So they are using digital and logic technologies. This may include temperature, frequency, continuity, capacitance, etc. So, as I said earlier, these are the advanced technology of analog meters. So, using this digital multimeter, you now can measure temperature, check frequencies, check the continuity, and also you can measure capacitance. So, these are, you can say, advantages of digital multimeter. Now, this is how your digital multimeter looks like. As you can see in the image, we will identify the different parts. So here, as you can see, these are input cables. Means when you purchase and digital multimeter, you will have these two cables, and these two cables are nothing but input cables to check or to see or to measure the different electrical quantities, you will need these cables. Here, this is LED LCD display on which you will get your output. Whichever quantity you are measuring, it will indicate its value over here. As this is a digital multimeter, it will give digital output only. Now here this is a selection probe. Using this you can change your functionalities. Like this is something you can say, change its functionality by moving it in clockwise direction or in anti-clockwise direction. So this is something like a probe or knob. You can move it in anti-clockwise and clockwise. And here in the bottom part, these are the input jacks. One is for voltage, current and resistance, and the other is common terminal. So here your input cables are connected and the other end will connect it to the socket, whichever quantity you are going to measure. Now usages of this parts means how to use, or means what are the functions of each and every section we have seen in this image are: first is display screen. It has illuminated display screen for better visualization. It has 5-digit display screen. One represent sign value and the other fours are for number representation. So here as you can see, this is a display which has illuminated screen on which you will get your output. Now here 1, 2, 3 and 4. This 4 represents digits of whichever quantity you are measuring. If you are measuring voltage of your cells, or you are measuring resistance of your resistor, so these are the 4 digital representation of that particular quantity. And here the first part, or you can say first segment, stands for its signal, means whether it is a positive, negative. So that is a sign value, and the latter 4 segments are there to display the output value, or you can say number. Thereafter there is a selection probe. As we know, a single multimeter performs so many tasks like reading voltages, resistance and current. This selection probe allows the user to select the different jobs. So using the selection probe, you can change the functionality, or you can change the range also. Here is if you want to measure AC voltage, so you can select and turn over your probe over here. If you want to measure DC voltage, then you just need to turn your selection probe over here in anti-clockwise direction. So using the selection probe, you can change your functionalities. Now input cables. Test leads are flexible, insulated wires, red for positive and black for negative, that plug into DMM. They serve as a conductor from the item being tested to the multimeter. The probe tips on each lead are used for testing circuit. So these are this provides nothing but a conducting path, just as a jumper cable or a wire, for connecting the digital multimeter to the circuit which we are going to measure the unknown quantity. So these are the cables in which this black cable is there for ground connection, and this the red wire is there for, you can say, positive or the higher level. Now port. There are two ports on the front of the unit. One is the MAV ohm port, which allows the measurement of all the 3 units: currents up to 200 milliampere, voltage and resistance. The red probe is plugged into this port. The other is common port. which means common, and it normally connected to negative of a circuit, and black probe is plugged into it. There is one particular port of 10 ampere which is used to measure large current in the circuits. So here these are three ports which we just talked about. So here the first probe is of 10 ampere, which is used whenever you are measuring large current. Then after there is a probe, which is there is an input jack, uh, to which your red cable is going to connected, and this is a common terminal to which your black probe is going to connect. Now display and dial settings. So the functionality we have just seen. So we will talk about this more in digital. This digital display, uh, what it does basically is it shows measured value. Whichever value we have measured is going to show up here. Then meter dial. It turns dial to change functions. Means if you want to measure AC voltage or DC voltage or resistance of unknown resistor. So this dial enables you to move through different functionalities. And also this dial is used to turn off your multimeter. If you if you set your dial just vertically straight, then it will turn off your digital multimeter. Now panel indicator. These sections are known as panel indicator. See, these are panel indicators. Here the different quantities are justified. For example, this panel area is for AC voltage. This panel area shows that you can turn off your digital multimeter by settling your probe here. This is a DC voltage area where you have different ranges of DC voltage. This is your resistance area. Here the different values of resistors is given. Here it is to check your LED continuity. Then HFE is used for transistor measurement. So these are different panel indicators, and thereafter there is a probe connection where you can connect your probes specific for function. Means here you will connect your positive and you will connect your negative cable over here. Now usages of different sections and buttons, how to use each and every section and button. So this button or this section particularly is used when you want to turn off your digital multimeter. This area is for AC voltage. This area is for DC current measurement. This area is to check the continuity. This area stands for ohms, means to measure resistance, and this area is to measure DC voltage. And whenever you want to check your test your transistors, you can use this area. And this is your positive terminal and this is your negative terminal. So now moving forward with our second part, which is application, the different applications of digital multimeter. So where you can use this digital multimeters are to measure voltages, both AC and DC, to measure current, mainly the DC current, to check continuity of cables, whether your cables are damaged or break has any breakages into it, or it is good and proper working condition. To check if diode is damaged or not, means to check whether your LED is in running condition or it is damaged. To measure the resistance of a resistor, to measure frequency and capacitance of the device of some devices, to check or test switches, batteries, outlets, light bulbs, and to determine if there is any fault in the circuit, you can also use a digital multimeter. So these were the application areas of digital multimeters. Now our third part of this lecture is how to use digital multimeter. So how you can set up and how you can start to measure the different electrical quantities. So these are the basic steps you can follow to use a digital multimeter. First is turn the meter on. Second, insert the probes into the correct connections. This is required because there may be a number of different connections that can be used. Set switch to the correct measurement type and range for the measurement to be measured. So if you want to measure your resistance, to switch or turn your probe into the resistance area properly. When selecting range, ensure that the maximum range is about that anticipated. So whenever you are checking, you are selecting range of you can say your resistor, to just be sure that your maximum value is not over your anticipated range. The range on the DMM can then be reduced as necessary. So if the output, if you are not getting output, then you can vary the selection area. So it is basically a trial and error method. However, by selecting a range that is too high, it prevents the meter being overloaded. So, by selecting range, matlab if you are selecting range too high, then it prevents the meter by being overloaded. Now, fourth step is to optimize the range of the best reading. If possible, enable all the leading digits to not read zero, and in this way the greatest number of significant digit can be read. Fifth is, once the reading is complete, it is a wise precaution to place the probes into the voltage measurement socket and turn the range to maximum voltage. In this way, if the meter is accidentally connected without thought for the range used, there is little chance of damage to the meter. This may not be true if it left set for a current reading and the meter is accidentally connected across a high voltage point. So these are the different functions of the whole digital multimeter accessories. The first is main display, which is there for display the measured quantities. Then rotary knob, the rotary knob which is used to select the desired scale. Then DC voltage measurement, it adjusts it to desired scale for measuring DC voltage. Then resistance area, ohm scales for measuring resistance. Now transistor jack, insert your BJT in the scale and check the HFE. Thermistor jack, a jack to which thermistor connects. Current probe jack, connect red probe to this jack for current measuring. Voltage probe jack, connect red probe to this jack for voltage measuring. Now common probe, always connect black probe to this jack. And temperature connect the thermistor to temperature jack and set the knob to degree Celsius. HFE, rotate the knob towards HFE while dealing with transistors. DC current, to measure the DC current, and AC voltage measurement, adjust it to desired scale for measuring the AC voltages. So now moving forward with our last and fourth part of this lecture, which is the measurement. Means how you can measure the voltage, resistance, the ampere, or check the continuity of cable, or check the diodes. How you can measure these quantities using a digital multimeter. So first we will see how to measure voltage using a digital multimeter. So in digital multimeter there are two parts for voltage measurement. There is one part to measure DC voltage, and also there is an AC voltage measurement available. So here what you will require to measure voltage is a multimeter, this digital multimeter, and we are going to measure voltage of a cell, 9-volt cell, or you can say battery. So you will require a digital multimeter and a cell of 9 voltages. So to measure DC voltage, we place the red lead into a voltage ohm com port and turn the dial or switch on to VDC, means the DC voltage section or panel area. If it is a manual ranging meter, then you can set proper range. Now we know that we have a 9-volt cell, then the best range would be of 20 volts. So now let's just discuss the steps. To measure DC voltage, we place first the red lead, which is here. The red lead into this voltage ohm port and the black probe. This is the black probe, and you will insert this black probe into this common port over here. Always connect the black probe first. Please guys, remember that whenever you are connecting these probes, first connect this black probe to this common port, and after that connect this red probe to this voltage ampere or resistance port. So now after connecting this both ports, now we have 9-volt battery. So here we will select this panel area using the selection probe. This is a selection probe which will you have to turn into anti-clockwise direction. Now we have a cell of 9 volts, so the best range of this would be here 20 volts, because see in this section we have available 200 millivolts, 2000 millivolts, 20 volts, 200 volts and 1000 volts. You can measure 200 millivolts up to 1000 volts. And here how you can see it is voltage DC is here we have V and there is a straight line suggests DC voltage, while here it is a V for voltage and there is a sinusoidal curve. This is the curve means it has changing magnitude, which also represents a sine wave. So this is a AC voltage sign and this is DC voltage sign. So whenever you are measuring the voltage of battery or cell, just select your probe area over here. We have a 9-volt cell, so you will select this range of 20 volts. Now, as an example, we want to measure 9-volt battery. So the best range would be 20 volts. If you have an auto ranging meter, you will only need, this is manual meter, but if in case you have auto ranging meter, you will need to set only function, means you want to measure voltage, so you will have to select just voltage quantity. So what are the steps? So first select the DC voltage range using selection probe, then connect the leads. First you will connect this common black probe to the common port, then you will connect this red probe to this voltage ampere port. Then after connect the two ends of these leads between the cell. Now this represents positive, this black or common represents to negative. So always place your cell with the positive sign over here and negative part of your negative terminal of your cell over here. So negative terminal of your cell and positive terminal of your cell, and place the cell in between here and check the volts of cell on display, and you will see you will get the output as 9. Now, how to measure AC voltage? That was all about DC voltage, but what we need to measure AC voltage? And to measure AC voltage, we place the red lead into the V ohm port and black lead into the common port. Turn the dial or switch. Now here we want to measure AC voltage, then we will have to turn the selection probe over here in voltage AC voltage panel area. For example, the meter would be set to the 200 volt range to measure a 120 volt outlet. Means if you have a device or something which have an output voltage of 120 AC, then you will have to select the range of 200 volts. If you have an auto ranging meter, then you will only have to select the voltage AC function. Remember that always connect black probe first and then the red lead. So this is how you can measure your voltage AC or DC. Now here second is how to measure resistance using a digital multimeter. To measure the resistance, you'll require a resistor of unknown quantity or known whatever and a digital multimeter. So to measure the resistance, first set the arrow of dial to the resistance section and connect first black probe and then red probe of digital multimeter with both ends of resistors. So here for an example, here you have a resistor. So first what you will do is you will connect this black probe to this common port. Then after connect this red probe. This red probe to this volt ohm port. Then this using these two leads connect the resistor in between. There is no tension of polarity, so you can connect either a lead onto a resistor. Then after what you will do is you will change this dial or this selection probe to voltage section or to resistance section. This is the resistance section. To measure the resistance, you'll have to turn your selection probe over here somewhere. If you are getting if you are not getting result, then change the value from 200 to the next one. Now this is I already said that this is a trial and error method. So if you don't know the resistance of this resistor, then start from the minor and then gradually increase the resistance range by selection port. If you are not getting any result, then change it to the next value. If you are not getting the result still, then go to the next selection range. And whenever you will have the correct resistance, then you will see the display like something like this. Then this is the result, or you can say then this is the resistance of your unknown resistor. So to the next one, and when a particular selection value, you will get the result, and on display you can see the value of that particular resistor. So until you don't get a result or any digits on the display, just change the selection area one by one. And when you get a digit, any digit on this display, uh, you will you will have your answer by that. So select first the range, then connect both the leads, first common or black probe and then red probe, and place your resistor in between these both probes and see the value on the display. So this is how you can measure a resistance of your unknown resistor. Now what about checking the continuity of cable? So how you can check the continuity of your cable using a digital multimeter. So for this experiment, you will need a cable or jumper wire and a digital multimeter. So what we are going to do here is we are going to connecting the cable, or you can say jumper wire, in between the two probes, black probe and red probe of digital multimeter in between the cable. Now to check the continuity of cable, first select the symbol of diode. As you can see here, this is a cable, this is a digital multimeter, and in digital multimeter connect the red probe which we have it to the voltage ampere ohm port and connect the black probe. Always first connect the common probe or black probe, this black probe to the common port. Now then after place the cable in between these two leads, and if you get and from selection probe, now you have connected this to the cable. Now what you will do is you change this selection probe range area, change it to the to a portion or panel where LED is drawn. So this is the this is the area for checking a cable. And if you get any sound, see, you will have display something like this, but if you are getting a beep noise or beep sound from digital multimeter, then you can say your wire is okay, whether it is or otherwise it is not. So after connecting, take one jumper wire or any cable for this and connect two probes to both ends of the cable. And if there is a beep sound, then the cable or jumper wire is okay or in running condition. And if there is no sound, then it can be said that the cable or jumper wire is damaged or may have some internal breakage as well. So what are the steps you'll need to follow is first the select the diode on digital multimeter using the selection probe. Connect both the leads. First connect this black probe and then connect this red probe. Put the cable or jumper wire in between these two leads. Put the jumper wire or cable in between these two leads. Then if beep sound means cable is okay. If there is any sound like beep, then your cable is okay, otherwise it is not. Now, how to check a diode using digital multimeter? Now our second part over here is to check your diode. To check your diode or to perform this, you will require a diode or an LED or a digital multimeter. So to check or test the diode, first select the symbol of diode. As we have done in previous case, the selection range or panel selection is the same area. So first select the symbol of diode seen on the digital multimeter. Take one diode or LED and connect the red. First, what you will do is first connect your black probe of digital multimeter to the one end of diode and then connect the red probe to voltage or ampere port and connect it to the other end of your diode. If there is any digit on display, then half part is clear. Now reverse the connection with diode. Now what you are going to do here is if you are getting any result with this connection, then your half part is clear. Now reverse means what you will have to do is the connecting ports means the terminal of diode which we have connected to the red probe will now be connected with the black probe. So by reversing the connection of probes on digital multimeter, and if there is no result on display, then the remaining other part is also clear. So first one was for the forward bias connection and the later half part was for reverse bias connection. If both half stages give these results, means in reverse connection, in forward first connection you are getting some result, and after that when you are reversing the connection and you are not getting anything as output or you are getting zero as output, then it means your diode is good, or you can say your diode has passed the test. Means in the first stage diode was in forward bias and gave result, while in other half stage when it was connected in reverse bias there was no result, which is the operation of a typical diode. What does a diode do? So basically diode allows a current to flow only in one direction, and it blocks the current when in this other direction. So it allows current to flow whenever it is in forward bias, and in reverse bias it blocks the current. So when you connect to the diode first time, and if it is giving a result, then you can say half part is clear. But when you are reversing the connection and you are not getting output, then joining both the stages, your diode performance is good. So this is how you can connect. So whenever if you want to check your LEDs with digital multimeter, then what you will have to do is take your LED. Now LED is your light emitting diode, and in that your longer leg of your LED would be your anode. and the shorter leg would be your cathode. So connect cathode with the black probe, and black probe goes to common port, and connect your anode, means the longer terminal, to this red probe, and connect this red probe to voltage ohm port, and select the area of where LED is drawn or diode is drawn by changing the selection probe. And if you are getting some result, something like this, then your half stage is clear. Now reverse the connection, means the port you are connected here, now connect this black probe to here, means a cathode to red probe and anode to black probe. And if you are getting this result, means zero reverse, means LED was in reverse bias, then it is giving output as 0. And if LED is connected in forward bias and it is giving some output, then your LED is without any damage, or you can say in running condition, or a good LED. Now this is similar to your diode. This is how your diode looks like. Okay. So when you are connecting your diode in forward bias and there is output and also a bip sound, then this is your diode which is in good condition, or you can say you can use it in your application. And when it is in reverse bias and it is giving you output as 0, then it is also a good diode. Now how to measure transistors current gain? So here is the another application of digital multimeter of getting the result of transistors. So in this section or in this particular experiment, what you will need is two transistors BC547 and BC557, the PNP and NPN transistors, and a digital multimeters. So steps, there are two separate sections available for PNP and NPN transistors. Place the leg as per the transistor type. So as you can see in digital multimeter, there is a dedicated area for transistor measurement. So this is the area for transistors. If you have PNP transistor, see we are using BC547 and BC557 transistor. So this BC557 is a PNP transistors. So the legs of this transistors are going to connect over here in PNP section, while the BC547 is a transistor of NPN type. So it is going to connect over here. So this part is for NPN transistors and this part is for PNP transistor connection. And whenever you are testing your transistor or you are measuring the current gain, you will always have to get your selection probe over here in HFE region. So using a selection probe, select a range of HFE, or turn your dial over to HFE section. This is the most part for transistor. Now place the three legs of transistor in these blue holes. These blue holes E, B, C, where E is emitter of your transistor, B is base of your transistor, and C is for common of your transistors, emitter, base, and collector. These are the indication of emitter, base, and collector. So now place the transistor in these holes and select HFE using a selection probe. And if the value is similar to that of current gain of that particular transistor, then you can say your transistor is good or in running condition, otherwise it is damaged. So how you will assemble this? So place the three legs of transistor in the first in the E, B, and C part, and the multimeter will show the reading if this information is correct, else it will show over range. Means if you have connected properly and if the transistor is in good condition, then it will give result in range, or else it will show you some over range. If the previous method doesn't work, place the three legs of transistor in the BCE formation. First, First we have put in E, B and C formation. Now if you are not getting any result, then change your formation by B, C and E. By connect first B, then C and then E in this form, and then check your result. If you are getting, now you will get results. If you are not getting result, then E, B, C will be correct, and if you are not getting in E, B, C form, then go for B, C and E formation. If the multimeter shows reading, then it's correct. The reading is nothing but HFE of the transistor, and HFE is nothing but hybrid parameter forward current gain for common emitter. So this is how you can measure the current gain of your transistor, or you can check your transistors. So thank you so much. This was all about digital multimeter.